Our next unit of study will deal with exponential functions. And an exponential function is a function in which the variable is the exponent in the form y equals a times b to the x power, where a is a non-zero constant and the variable b has to be greater than 0 but cannot be 1. When you are graphing exponential functions, you can use ordered pairs just like we've done in the past with slope and y-intercept using ordered pairs to graph the exponential functions. You need a list of domain values, which are your x values, to substitute into the equation for the exponent, and then solve to determine your range values or your y values. And this list of ordered pairs, -3, -2, -1, 0, 1, 2, and 3, are a good list of domain values to use to get a good graph. Because you want, several of the domain values, not just a few. Graph the exponential function using the function y equals 2 to the x power using the table. And I gave you these domain values right here, -3, -2, -1, 0, 1, 2, and 3. And I figured out these, substituting these domain values in for this exponent. So, for example, y equals 2 to the x power. Well, when x is -3, then y will equal 1/8. So the ordered pair will be -3, 1/8 for y equals 2 to the -3rd power. Another example, y equals 2 to the -2 power. Well, when your exponent is negative, that means to do the reciprocal. So instead of this being, to make it positive, you do the reciprocal of what you have. So instead of this being 2 to the -2 over 1, it's going to be flipped to 1 over 2 to the positive 2. And that will make y equal to 1/4. Here, when x is 0, then y is going to be 1, because anything to the 0 power is going to be 1. And then when x is a positive 3, then 2 to the 3rd power is 8. And remember, don't count 2, 4, 6, 8. You have to actually multiply. You have to actually double each time, because we're talking about exponential growth. So 2 times 2 is 4, and then 4 doubled will be 8. So y will be equal to 8. If you look at this graph, I took these points right here that are easier to plot, and 0, 1 is where your y-intercept is, because x is 0, y is 1. So that's where this graph is going to cross the y-axis at 0, 1. And I plotted that point there, and then I plotted these 3 points because they were easier to plot than the negative domain values were. And when you see this line right here, it looks like it's touching the x-axis, but it's really not. It'll get really, really close, but it doesn't actually touch the x-axis. And this is what your graph will look like for y equals 2 to the x power. Now, if you do the opposite of this function, which would be y equals -2 to the x power, which is the opposite of 2 to the x power, then everything will be the opposite, meaning if it was positive, it will become negative. If it was negative, it will become positive. So if I had y equals the opposite of 2 to the x power and x is -3, when x was -3 on the last function, y equals 2 to the -3, we got 1/8. So the opposite of 1/8 would be -1/8. So what you would do is you would still flip. Instead of this being 2 to the -3 over 1, it would be 1 over 2 to the positive 3, but the opposite of that. So this will be -1/8. Same thing here. When you have x equals 3, I put a positive 3 in there. I don't have to do the reciprocal because my exponent is not negative. So I just do 2 times 2 times 2, which is what 2 to the 3rd is. I get 8. And then this negative sign tells me the opposite of that. So the opposite of what's in parentheses, which is 8, is a -8. So when for the function y equals the opposite of 2 to the 3rd power, or -2 to the 3rd power, then y will be equal to -8 when x is positive 3, and you're doing the opposite function of y equals -2 to the x power. This is what your graph will look like. In your graph, this line will never touch the x-axis. It comes very, very close, but it never actually touches. And I graphed also, again, these same points because they were easier to graph, the 0, 1, 2, and 3 as my domain and their respective ranges. And so I got this graph, and it's the opposite of the graph before because this is the opposite function. So my graph is decreasing. And that is exponential functions.